Assalamualaikum. Okay, so kita masuk chapter 4, Alkanes. Okay, alkanes are the hydrocarbons of aliphatic rows. Okay, alkanes are hydrocarbon in which all the bonds are single covalent bonds, which is sigma bonds. So an alkane is a saturated hydrocarbon whose carbon atom are arranged in open chains, and alkanes are commonly referred to as aliphatic hydrocarbon because of their physical properties of the higher member of this class resemble those of the long chain molecule that we can find in animal fat and plant oil. Alkanes are aliphatic hydrocarbon that having only carbon-carbon single bond and carbon-hydrogen single bond. Because of their carbon atom can be joined together in chains or rings, they can be categorized as acyclic or as a cyclic. Acyclic alkenes have the molecular formula CnH2n plus 2, okay, and contain only linear and branch chains of carbon atom. They are also called saturated hydrocarbon because they have the maximum number of hydrogen atom per carbon, sebab dia hanya mengandungi single bond. So dia mempunyai that carbon contain the maximum number of hydrogen. Cycloalkanes contain carbon joined in one or more rings. Because of their formula CnH2n, they have two fewer hydrogen atom than an acyclic alkane with the same number of carbon. Okay, as you can see here, all carbon atoms in an alkanes are surrounded by four group of atom or four atom, making them sp3 hybridized single bond, and they are tetrahedral. All their bonds angle are 109.5 degree. Okay, so the 3D representation and ball sticks model for these alkanes indicate that tetrahedral geometry around each carbon atom. Okay, in contrast, the Lewis structure are not meant to imply any 3D arrangement. Additionally, in propane and higher molecular weight of alkane, the carbon skeleton can be drawn in a variety of ways and still represents the same molecule. Okay, alkanes can have either simple unbranched or branched carbon chain. Alkane with unbranched carbon chain are called normal alkanes or N-alkanes. Carbon atom in alkanes and other organic compounds are classified by the number of other carbon directly bonded to them. For example, a primary carbon is bonded to one other carbon atom. Okay, that is primary carbon. Secondary carbon is bonded to two other carbon atoms. Tertiary carbon is bonded to three other carbon atoms, and quaternary carbon is bonded to four other carbon atoms. Okay, cycloalkanes have molecular formula CnH2n and contain carbon atom arranged in a ring. So simple cycloalkanes are named by adding the prefix cyclo to the name of alkane of the acyclic alkane having the same number of carbon. Okay, for example, C3H6 is cyclopropene. Okay, with 4 carbon atom, and it is in a ring, so we call it as cyclobutane. For 5 carbon atom, cyclopentane. Alright. Ideally, every organic compound should have a name that clearly describes its structure and from which a structural formula can be drawn. For this purpose, chemists have adopted a set of rules established by a governing board called IUPAC system, International Union of Pure and Applied Chemistry. IUPAC names of alkene with an undrawn chain of carbon atom consists of 2 parts. First, a prefix that indicates the number of carbon atom in the chain, and the second part is suffix. Suffix for alkane is "-ane" to show that the compound is a saturated hydrocarbon, to show that the compound is alkene. So the prefix used to show the presence of from 1 to 20 atom as shown in the table. The name of every organic molecule has 3 parts. The parent name indicates the number of carbon in the longest continuous chain. For example, 6 carbon, so the name is hexane. Okay, hexa, so hexane. The suffix indicates what functional group is present. Okay, the suffix. The prefix tells us the identity, the location, and the number of substituents attached to the carbon chain. Okay, for the rules of the IUPAC system for naming alkane, first the general name of saturated hydrocarbon is alkene. Then for the second, for branch chain hydrocarbon, the alkene corresponding to the longest chain of carbon atom is taken as the parent compound and its name as the root name. For example, 6 carbon, so the name is hexane. For the 3 carbon, so the name is propene. Then the third one, the group attached to the parent chain are called substituents. So each substituent is given a name and a number. So the number shows the carbon atom of the parent chain to which the substituent is attached. Okay, for example, CH3, CH3, CH3. Okay. Okay, so 1 carbon, 2 carbon, 3 carbon. So 3 carbon is propane. Okay, 1, 2, 3. At carbon 2, we have methyl. Okay, so the name is propane. Okay, and at carbon 2 we have methyl. So 2-methyl propane. If the same substituent occurs more than once, the number of each carbon of the parent chain on which the substituents occur is given. In addition, the number of times the substituents group occur is indicated by a prefix. Kalau dia 2 kali, so di. Kalau dia 3 kali, ada 3 methyl, so tri. Kalau 4, tetra, and so on lah. Okay. Then, if there is one substituent, number the parent chain from the end that give it the lower number. Okay, yang paling hampir dengan substituent dia. If there are 2 or more identical substituents, number the parent chain from the end that give the lower number to the substituent encountered first. Okay, if there are 2 or more different substituents, list them in alphabet order and number the chain from the end that give the lower number to the substituent encountered first. If there are different substituents in equivalent position on the parent chain, the substituent of lower alphabet order is given the lower number. Okay, for example, one, two, three, four, five. Okay, 5 carbon. Okay. At the second carbon, there's methyl, and at the okay, here is methyl. So the rest is hydrogen. Okay, so 1, 2, okay, 1, 2, 3, 4, 5. 5 carbon is pentene. At carbon 2, okay, there is a methyl. And at carbon 4, methyl. Okay, so the parent chain is pentane. Okay, carbon 2 and 4 methyl, so di. 2, 4 dimethyl pentane.